Let's do some more reductions with co-function questions. In the previous video, I explained what co-functions are. I gave you a little bit of a cheat sheet or a summary in order to work out what happens if we have a 90 degrees or 270 degrees. So if you missed that video, please go watch it first right now before you carry on watching these examples. I've also gone through the steps in slower detail in the previous video, but we're just going to jump right back in to the next few examples. So let's do example 3. So step 1, the question will say simplify. I've left out the instruction, but the question will say simplify. And you will see this, and you know that you need to do reduction. So the first on the numerator over here, I've got sin of 90 minus theta. As soon as you see a 90 minus or a 90 plus, you know you need to use your co-function rule. So when you see a 90 or 270, just like I have here, you use your cast diagram, all stations to Cape Town, to check what quadrant you are in. So according to what I've written on my cast diagram, you'll remember in previous videos, we also have things like this is 180 minus theta, this is 180 plus theta, very important, 360 minus theta, and this is theta itself, and this is negative theta. So that's our full little cast diagram so far. We have got 90 minus theta, which, as I explained in the previous video, is in this quadrant over here, 90 minus theta, the all quadrant. In other words, all of my ratios are positive. So all my ratios are positive. We need to look at the original question. So in the previous video, I spoke about how I actually swapped step 3 and 4, but it doesn't matter. You look at your original trig ratio, which is a sin. And in the A quadrant, sin is positive. So when I reduce, it's going to become positive. Because it's a 90 or 270, you change from a sin to a cos. Drop the 90 and you've got a theta like that. Then I've got sin theta next. I'm putting it in brackets because it looks easier for me, that it seems more obvious that it's multiplication. Here you can see that I'm multiplying. Then in the denominator, I've got cos theta, positive cos theta. And then I have to apply my co-functions rule again. Cos of 90 plus theta. Now listen to me very carefully. 90 plus theta takes me into this quadrant over here where sin is positive. We need to look at the original given in the question, which is cos. I'm in the S quadrant where sin is positive, but I'm dealing with cos. Cos would therefore be negative. You then need to change it from a cos to a sin, and then you drop the 90. So just to be clear, when you are dealing with co-functions, when you see a 90 or 270, if the original question said sin, your answer must say cos. Well, when your second step here, it goes from sin to cos and from cos to sin. They need to switch. You determine the sign here, if this is a positive or a negative, based on the original. So 90 plus theta is in this quadrant where sin is positive, but my original ratio is a cos. So that's why this is a negative. Now, obviously, I'm not done with this question. I need to simplify. So cos theta cancels with cos theta. Sin theta cancels with sin theta. I'm left with positive 1 at the top divided by negative 1 at the bottom. So my answer is negative 1. So keep the steps in mind. Try this one yourself. And let's mark it together. So cos of 180 minus x, remember on my diagram, I've called it theta, but here they're calling it x, it's fine. 180 minus x would be this quadrant over here where sin is positive, but I've got a cos, so cos would be negative. So negative cos x. Take note, I'm not switching this from a cos to a sin because I am not dealing with a co-function. This is 180. We only do co-functions if you see a 90 or 270. Then, next one, I've got cos of 90 minus x. 90 minus x is this quadrant over here, where all are positive. So that means that all is positive, which means cos will be positive, which means my answer is going to be positive here. But because this is a 90, I need to change my cos to a sin. So sin of x. Then my next one, I've got tan of negative x. Remember, previous lessons, we said the negative angle, negative theta, negative the acute angle is down here. Because if you go this way, you plus. If you go this way, you minus. So this would be negative theta, which is in the C quadrant where cos is positive. But I'm dealing with tan. So tan would be negative like that. Now let's do the denominator. Sin of 180 plus x, that's fine, that's nice and easy. We know where that is. That is in this quadrant over here, where tan is positive, but I'm dealing with sin, so sin will be negative, like that. And then sin of 90 plus x. As soon as you see the 90, you know it's co-functions, co-ratios. So 90 plus is in this quadrant over here, where sin is positive. And my original ratio is a sin, so my answer is going to be positive, but because it's a 90, I have to change it from a sin to a cos, like that. And now our last step is to simplify, because the instruction of the question will say simplify, just by the way. So we know we can do some cancelling out over here. I can cancel my sin x and my sin x, my cos x and my cos x. So at the top, I'm left with -1 times negative tan x. And at the bottom, remember, I didn't cancel out my negatives. I could have actually said this negative here cancels out with that negative there. So then at the top, I would have been left with negative tan x, and then that's it, divided by 1. So my answer is negative tan x. My next one looks simple, but it's actually interesting. If you look at it quickly, you will think, oh, theta minus 90, okay, cool, that's, yeah. But remember, we've done a whole lesson on negative angles. 90 minus theta is a very different thing to theta minus 90. They are very, very different. They're not the same. This one includes a negative angle. So when you have a negative angle like that, just like in the lesson that I taught you on negative angles, we may add or subtract. In this case, I'm going to add a revolution. So add 360 degrees. So that leaves me with sin of theta, then negative 90 plus 360 is 270, positive 270. We know another way that we can write that is just with the 270 first. That is maybe more like we may be more used to seeing it like that. 270 plus theta, theta plus 270, same thing. And 270 plus theta is in this quadrant over here. Remember, this is 270. If you go this way, you're going smaller than 270, so it's 270 minus theta. If you're going this way, you're going bigger than 270, so it's 270 plus theta. So we are in the cos quadrant. Now, this is very, very, very important. Listen very carefully. Because it is a 270, and remember we said with our cofunction rule, every time you see a 90 and a 270, you know that we are going to change our ratio from a sin to a cos or a cos to a sin. So because I see a 270, I know I'm going to change this from a sin to a cos. You drop the 270 and you end up with a theta. But we also have to determine the sign over here. So I'm basically going back to my steps that I showed you earlier. Is this a positive or is this a negative? It all depends on the quadrant. And we have to look at the original to help me. So 270 plus theta is, as we said, in this quadrant over here, where cos is positive. But we look at the original. The original is a sin. But I am in a quadrant where cos is positive. The original is a sin, which means that my answer here must be a negative. So always look at the original when determining the sign. Example 6 is interesting because there's actually two terms over here. This is a term and this is a term. Remember, terms are separated by pluses and minuses. That's the first thing I want you to be aware of. In previous examples, we've dealt with fractions and things like that, or things that are one term. So let's see what happens. How does this affect my answer? Sin of 180, so the question will say simplify. Sin of 180 minus theta, 180 minus is here in the quadrant where sin is positive. And I'm dealing with sin, so it's going to be positive sin theta. Okay, you do not change this from a sin to a cos because 180, that's not a cofunction. We only do it with 90 and 270. Then I've got multiplied by cos of 90 plus theta. 90 plus theta is this quadrant, actually the same quadrant, where sin is positive. But my original ratio is a cos, and I'm in a quadrant where sin is positive, which means that I need to make this negative, and then I'm changing it from a cos to a sin, and then I put the theta over there. So because it's a 90, we go from cos to sin, and we use the original, which is a cos, to determine the sign. Sin is positive here, so cos would be negative. The original determines the sign. Then, very important how you write this next step. This negative is here, still separating the two terms. Next one, sin of 90 minus theta. That's this quadrant where all are positive, which means this is a nice quadrant to be in. We don't even have to think very hard because everything is positive here. So my answer here is going to be a positive. It's going to be positive. Oh, not sin, you see? Be careful of working too fast because it's a 90. We have to change it from a sin to a cos, like that. And then I've got cos of 360 minus theta. That would be in this quadrant here. 360 minus, where cos is positive, and I am dealing with cos, so it's going to be positive cos theta. Now, very, very important. This minus separates two terms. Can we simplify this? So positive sin theta multiplied by negative sin theta. Well, a positive multiplied by a negative is a negative. Sin theta multiplied by sin theta is sin squared theta. Then we drop the negative down here, separating my two terms. Cos theta multiplied by cos theta is cos squared theta. Now, in a test and an exam, this would not be the simplest that we can do this. If you've done identities already, you will recognize that this looks almost like one of our identities that we know. I do identities in later videos in this playlist, but one of our identities is sin squared theta plus cos squared theta is equal to 1. That is one of my identities. And take a look here. I know we don't have sin squared theta plus cos squared theta, but do you see we have two terms? And both terms have a negative 1 in them. This is negative 1 sin squared theta and negative 1 sin squared theta. I can take a negative out. We can factorize. Take out a negative, and we will then be left with positive sin squared theta plus cos squared theta. Remember, if you had to multiply this back in here, you would get this step over here. So all I'm doing is I'm factorizing, I'm taking out the negative, and then if you look inside this bracket, sin squared theta plus cos squared theta, we know that that is equal to 1. So this whole bracket turns into a 1. So technically my answer, simplified here, is negative 1. More identity videos are coming up, so don't worry if you are still a little bit lost, but that is it. Let's do one more cofunction question over here. And that looks like this, and this one looks maybe simple to you. So sin of 180 minus theta, that's here, 180 minus theta in the quadrant where sin is positive. I'm dealing with sin, so it's going to be positive sin theta. Now, this cos 20, I'm going to leave it there for a second. I will show you something now. Then cos of 180 plus theta, 180 plus theta is over here, where tan is positive, but I've got a cos. So that means that this must be a negative cos theta. Now, what I want to show you, and if you know and understand cofunctions, you will say, but ma'am, these two, they just cancel. Why are they allowed to just cancel? Remember what I told you in the previous video, and we've been discussing it here. Co-ratios are like this. Cos of an angle is equal to sin of 90 minus that angle. So in this case, if my angle is 20, sin, what's 90 minus 20? 70. These have the same value. And if you don't believe me, type it into your calculator. Type cos 20, get an answer. Type sin 70, get an answer. They have the same numerical value. So yes, you technically can cancel these, but to show your teacher that you have understanding of cofunctions in your test, I want you to pick one of them and transform it into the other. So what I'm saying is cos 20 is my numerator. So we're going to show the teacher, or me, I'm the teacher, you're going to show me that you understand that sin 70 is the same thing as cos 20. So you're just turning that into that because they are the same, and then we can cancel those. I hope that makes sense. And then I've got sin theta divided by negative cos theta. So that is negative sin theta over cos theta. And again, if you know your identities, you should know that sin theta divided by cos theta is equal to tan theta. So this becomes a tan theta, and that is therefore my answer. I hope that that has helped you understand cofunctions. In the next videos, we'll go over reduction involving numerical angles, where we have to use special angles. You'll know how to do things like reducing this or simplifying this without a calculator and things like this. And later on in this playlist, I also cover identities. Bye everybody, I'll see you in another video.